This is our stats final presentation by Evan, me, Brett, Brennan, and Peyton. All right, so this is the background for seat direction. We're going to be addressing the issue of what factor results in the best test score, such as direction sitting. And so we ran tests comparing the variables looking for a correlation and a p-value. And then so we ran tests for this question looking for values we could deem substantial.
So this is our description of data for both tests. We have it split up into numeric and non-numeric variables, and the ones in bold you'll see are the ones we used for our hypothesis. The score on test 1, 2, and 3 on the left side under numeric, and the time taken to complete the test 1, 2, and 3. We also have on the right side, we have which semester the class was taken during, which section the class was, the person's gender, the version the class was taking for test 1, 2, and 3, and when the person turned in the test compared to the rest of the class, 1, 2, and 3, which direction the person faces in class, how many years they have been at Elon, so first year or other students, and whether the class is all first year students or not. So for our first test, we had seat direction. For each student, Dr. Metz noted whether the student was facing towards her at the front of the class or away from her towards the walls. We looked at this correlation to see, comparing it to test scores, and we tested to see if those who sat forward facing the teacher scored better than those facing away. And this bar graph on the right shows which ones are facing forward and how many are facing away, and that's going to tie back in later.
For the statistical methodology for direction, after every test, Dr. Metz would make note of the rank when each student turned in their test. So if they were the first student, she would write 1. If they were the second, she'd write 2. And then she took note of how long each student took to complete each test. That data was then combined with the other semesters and sections of the same class to compare the results. We decided to look at how the direction the student was facing in the class impacted their test score. The reason we looked at that information was so that something could be easily modified in the classroom. The teacher could change the way their class is set up to have all students facing them. That way, that would hopefully increase all of the students' test scores, resulting in a higher overall score.
This is the data that correlates each of the 3 test scores with which direction they were facing. For test 1, we can be 94% confident that those facing away performed worse than those who were facing towards the teacher, as shown by the 94% confidence interval, not capturing 0. For the other 2 tests, we can be over 95% confident in this assertion, because the 95% confidence interval, as shown in the table, does not capture 0. The graphs also show this because the graph on the bottom has distributions further to the right, indicating higher test scores for those who were facing towards her during the class. You can also look at the box and whisker plots, which were always further to the right, indicating higher test scores for those who were facing towards her.
So the background for first year, we're going to be addressing the issue whether or not the classes that were only first year students resulted in higher test scores than the classes that also included upperclassmen. So we ran tests comparing the variables to see if there was any correlation, and to do this we ran an ANOVA test.
Dr. Metz noted which year each of the students were and whether they're in a first year only class or not, which is shown below in the bar charts. We use this correlated with test scores to determine whether this had an effect on the test scores. In the bottom left down here, we have whether they're in a first year only class or not. And in the bottom right, it's the proportion of first years to other students across her classes.
For the statistical methodology for first year classes, after every test, Dr. Metz would collect data based on the scores of all the tests, which were then combined with other semesters and sections of the same class to compare the results. We decided to look at the class that only had first-year students and the class that had a mix of first-year students and upperclassmen to see if their test results differed based on the class they were in. The reason we looked at this information was to see if the class the students were in impacted their test results. We thought this was an insightful question because many first-year students likely took AP Statistics or other similar courses more recently, which could have impacted their scores. Having more recent prior knowledge could have benefited them, resulting in better scores. If they were in a mixed class, the upperclassmen in that class may have not had as much more background knowledge, which impacted their scores in their tests.
We ran an ANOVA test that compares the year of a student's undergraduate education to each of their test scores. The scores for the freshmen were well greater than those for sophomores for the third test, allowing us to conclude that our hypothesis that recent education and high school stats have a significant impact on their ability to learn it is true. The p-value in the top right corner of test 3 the test 3 distribution indicates that the conclusion of first years performing better is a valid one. The data was less conclusive for the other two tests in the year, though. It should be noted that the data has very few observances from sophomore, junior, and senior classes, which makes it hard to draw a conclusion about the difference in test scores. Juniors only appear in the distribution for test 1 because there were a total of 2 juniors in the entire data set, with one of them dropping out before test 1 and one of them dropping out after test 1. This is the conclusion for whether first year only classes affected the test scores. We used a t-test to compare each of the test scores for the students in first year only classes to the test scores of students not in first year only classes. The distributions for those that were in first year only classes were consistently higher and to the right of the distributions for those who were not in first year only classes. This suggests, although not outright proves, that our assertion is true, that those in first year only classes would score better. This can only be moderately concluded though, because the 95% confidence level generally captures 0, and it can only be determined with 93% confidence that they performed better on test 3. This is the overall conclusion for the whole slideshow presentation. There is strong evidence to state that students facing towards the teacher score higher on tests than those that were facing away from the teacher. There is moderate evidence to state that freshman students scored better on tests than those of other grades. And there is moderate evidence to state that students in freshman-only classes scored better than those who were not in freshman-only classes.